Hello children, this is your physics teacher Sharma and I welcome you all back to my class again. I know you are pretty well excited to see your question paper today. I know you are going to give your science exam today. The syllabus for your science examination, that too the physics part, is sound. So in this class I would like to just give a recap to today's test topic, that is sound. We actually classified musical instruments into three types. Okay, first we start with percussion instruments, or these are otherwise called as brass instruments. These include a vibrating membrane. Drums, tabla, mridangam, these all come under percussion or brass instruments. Next we have wind instruments. Wind instruments include clarinet, flute, okay, pipe, and even a mouth organ. Now these are the instruments in which when we blow air, they actually move into those openings, fine gaps and openings, and they produce different sounds, and the sound that is produced is actually changing with the length of the vibrating air column. So in the previous case, that is percussion instrument, we have the membrane that is vibrating, and in case of a wind instrument we have the air itself vibrating. Now coming to the third category, that is a string instrument. In case of a string instrument we have guitar, sitar, veena, okay, violin, wherein actually a string will be set to vibration. That vibrating string will produce the sound. Now finally, what do we actually conclude by this? We conclude that whenever something is vibrating, sound is produced. By this we can define sound as a form of energy which is produced by a vibrating body. Now coming to the next part, that is the sound produced by human beings. Okay, we have a very small organ here at the throat which we call as voice box or larynx. Okay, that has a pair of vocal cords. So this is called the voice box. Voice box has two thin membranes which we call it as vocal cords. Voice box has vocal cords. Now when we talk, we are actually forcing the air from the lungs into the voice box. So when I am talking, I take in some air, I breathe in, and I allow that air to come out of this voice box. That is when these two membranes, they are sometimes close to each other, sometimes very narrow gap, sometimes broader gap, depending on what sound should be produced and how loud it should be produced. Okay, so we have a pair of vocal cords, and that is present exactly at the top of the windpipe. So we have the windpipe here. At the top of the windpipe we have this voice box. Now coming to the part of hearing. Yes, human ear. Human ear is that organ of the body which is very close to the brain. At the same time, it is the part of the body which gives us the sensation of hearing. We will be able to hear something because of ear. Now, inside our human ear, there is a very thin membrane, and that membrane is called eardrum. Okay. So that eardrum is so sensitive that any sound that is produced around it will start vibrating. Okay, those vibrations are carried to our brain in form of pulses, signals, and that causes a sensation of hearing. Now, there are few activities which are there in the textbook which you might have definitely gone through. Okay, which explains that when we talk, the vocal cords vibrate. Is it that whenever wind is blown between two membranes, sound is produced? For that, there is one activity given which we actually followed in one of the previous videos, wherein we take a piece of paper, two slips of paper, we fold it, and when we blow air through it, it produces sound. So whenever air is being blown through a narrow gap, sound is produced. Okay, so that activity we can see And there is also an activity which proves that whenever we are talking, those vibrations are carried forward, and it makes the other substance also to vibrate. Now, what is vibration? When I am actually talking, what am I actually doing? I am setting the particles of air which are in front of my mouth into motion. They are moving forward, they are colliding with the particle which is there in front of them, and again they are coming back to their original position. Again they move forward, come back to their original position, like the to and fro motion continuously taking place. Okay, that is called vibration. Okay, now when I talk, it is because of the vibration of my vocal cords. Those vibrations are coming out of my mouth, they travel through the air, and they will be reaching the ear. In the same way, to explain how the eardrum works, there is one activity described in the textbook again. You take a hollow cylinder, or you take a plastic bottle with its bottom cut. To the top of that, we tie a balloon, a rubber balloon, and just drop some mustard seeds on it, so anything which is lightweight. Now, from beneath, when you talk, the vibrations coming from the mouth will be going, and you actually notice that these mustard seeds will be jumping. That means when I am talking, these vibrations are carried to the membrane, that is the balloon, and the balloon membrane started vibrating, which makes the mustard seeds jump up and down. Okay, so when we are talking, we are actually setting some other particle into vibration. So this is how our eardrum works. Now, there is one question which usually rises in everyone's mind. Is it that a person who is impaired, audio impaired, that means he cannot hear, will remain dumb, that means he does not speak, he will not be able to speak? Is it that a person who is having hearing disability will end up being vocal disability or talking disability? Yes, we will be able to hear, understand, we will be able to understand and reproduce only if we hear something. Okay, if I hear a sound, I will know what is the meaning of the sound, I will know how to produce that sound, and then I start using that sound. So what is happening if I don't hear the sound? If I cannot hear the sound, then I will not be able to say it again. So it is very often that a person who is having hearing disability will end up being a person with speaking disability. Okay, now coming to the next part, propagation of sound. We come across a term called medium. Medium is anything which allows a form of energy to flow through it. Okay, now when I am talking, the sound is reaching you because there is something between you and me, that is the air, and that air is allowing the sound to travel to you. I take a light, a torch, I allow the beam of light to pass through a glass slab. I can see that the light which is going from one side of the glass slab is coming from the other side of the glass slab, because glass is a medium of light. Okay, so any substance which is allowing a form of energy to flow through it, we say it is a medium. Fine, good. Now, does sound travel through everything? Let us see, because most of you have been into a swimming pool for your swimming classes. Next time when you go to swimming pool, hopefully very soon, okay, you just try to produce some sound, like you try to strike a bell with a hammer, or you just try to clap, make some clicking sounds by the fingers, and try to see if the other friend of yours who is also in the pool completely to the bottom of the pool with ears under the water, will he be able to hear the sound or not? Let me tell you, whales, sharks and different types of fishes, they actually communicate with each other even from a distance of 100 miles. Isn't it amazing? This is actually bringing into light a fact that sound travels through water. Okay, sound travels through air, that we know, because whatever sound I am producing you are able to hear. Now coming to solids. can sound travel through solids? This is a common practice or a prank we do whenever we just keep our head on the desk. Every little detail of the sound, for the sound of a pen being placed on the table or a pen being taken from the table, also we will be able to hear the sound very clearly. A sound which we will not be able to hear when we are normally sitting will be heard very clearly, in fact more loudly, if you keep your ear to the desk. Okay, now this shows that the sound that is produced by moving the pen or placing the book is actually traveling through the solid, that is the dust, that is the wood here. You know, there is also a method which the ancient Red Indians used to follow. They used to keep their ear flat to the floor, to the ground, to see if there is any enemy troop. You know, like Red Indians were usually hunted by that area local people, I believe it is Americans. So what they do, they used to keep their ear close to the, like they used to rest their ear on the ground, okay, and they used to observe if they can hear the sound of the horse hoof, and based on that they not only used to know how far they are, but they also used to know from which direction the horses or the troops are coming. So this is actually an indication that sound is traveling along the ground. Now there is also a common practice, like no, it is only done when like we are far from danger, that we keep, like some people keep their ear on the railway track to hear a sound, the sound made by the train moving on the track. Okay, if the sound is very loud, that means the train is very close, maybe a kilometer away or so, or even less than a kilometer away. Okay, if the sound is feeble, then it is far, and if you are not able to hear the sound, that means the train is very far. Now, that sound is actually able to travel, the sound made by the wheels when it is passing over every joint of the rail is traveling some kilometers. Okay, not 1 or 2, but definitely more than 5 to 10 kilometers. So that much distance the sound is traveling through the rail. That means it is actually traveling through solids. So sound is traveling through solids, sound is traveling through liquids, and sound is definitely traveling through gases. So now what if I deprive sound waves from all these things? That is the Belger experiment which we have learned. Okay, if I take a bell jar, a huge jar, fill it, like I fix an electric bell into it and put it over a rubber sheet and I ring the bell, okay, I can hear the sound very clearly. Now what I will do, I will use a vacuum pump and slowly evacuate it. I will try to take the air out of it. Then what happens, we feel that the sound slowly decreases, and finally we can see the hammer striking the gong, but the sound will not be heard. It is because the air, which is behaving like a medium, is being taken away. So automatically what happens, there is no medium which can transport the sound from one place to another place, so the sound does not travel. So from this we understand that sound needs material medium for its propagation. Sound cannot travel through vacuum. Okay. Now coming to the characteristics of waves. Okay. Sound is actually traveling in form of waves. Okay, we represent that by means of a transverse wave. A wave will necessarily have three quantities: wavelength, frequency, and time period. Now what is wavelength? The distance between two successive points which are in the same phase is called wavelength. Okay, or else I can say the distance between two crests or troughs. In case of sound waves, the distance between two compressions or refractions, we call it as a wave. Okay, now coming to frequency, or in simple, wavelength is nothing but the length of the wave as given in your textbook. Okay, more about these waves we'll be discussing in higher classes. Now coming to the next one, that is frequency. Frequency is nothing but the number of waves produced in a unit time. Okay. If I say the frequency of a tuning fork is 480 Hertz, that means in 1 second the prompts of the tuning fork will be vibrating 480 times. Imagine, this is in 1 second, it is vibrating 480 times. That means if this is the prompt, this is the mean position, it is at extreme position. From extreme position to opposite extreme position and coming back to the first extreme position, this makes one vibration. Like that, it will be vibrating 480 times in 1 second. So that is frequency. Okay. Now time period. The time taken for producing one complete wave is called the time period. Okay. Now you see, wavelength is nothing but the length of the wave, which is measured in meters or centimeters. Coming to frequency, frequency is the number of waves produced in unit time, usually in 1 second. It is measured in hertz. And last but not least, time period. Time period is nothing but the time taken for producing one complete wave. Okay. Now coming to the next part, that is noise and music. We are actually very familiar with both. Okay. We call something as music if the sound is following a regular pattern and it is pleasant to hear as well. If the sound is pleasant to hear and it is following a regular pattern, we say it is a music. On the other hand, if the sound is irregular and not pleasant to hear, then we say it is noise. Also, when I said it is being pleasant or unpleasant, please do understand, if the sound is high also, it is not pleasant. Even though it is a sound of a piano or a violin or a guitar, which is very nice to hear, we like it. But the same sound, if I use a couple of amplifiers and install and set up a very big speaker and put it in front of you, you will not be liking it. You actually feel disturbed. Okay, it is very disturbing. So that is called noise pollution. If the sound that is produced, which is measured in decibels, the intensity of the sound, let us also mention about amplitude. Amplitude is actually a measure. It gives us the amount of energy a sound wave has. I said the particles are getting displaced, moving forward, coming back, moving forward. So that displacement, the maximum displacement undergone by the particle of the medium, we call it as amplitude. Okay. Now, if the amplitude or the loudness, which is measured in decibels, is more than 80, then it comes under noise pollution, which is really unbearable. Okay, so what we can do to get rid of this pollution, there are many things which we can do, like try to use a proper sound reducing instruments like proper silencer to the vehicle. Try to grow more plants along the roadsides. If we have plants, let me tell you, soft material will always absorb the sound, it will not reflect the sound. So whenever there is a soft material, that's the reason why in cinema theaters the walls are actually carpeted, or they will be having wooden walls or wooden floors and carpeted floors, because sound will not be reflecting back, sound will be absorbed, and so they are very pleasant. Now if we are actually having trees and plants on either sides of the road, definitely all the sound that is produced and which is way above the capacity which we can hear, that will be absorbed by the plants because they are soft and tender, so sound pollution can be decreased. Okay, here I would also like to bring to your notice, like introduce one small topic, that is ultrasonics and infrasonics. If the frequency of sound, what we are hearing, is less than 20 Hertz, we cannot hear it. Okay, so these sounds which are less than 20 Hertz of frequency are called infrasonics. On the other hand, those sound waves which are having frequency more than 20,000 Hertz, those are called ultrasonics, and those also we cannot hear. Okay, so let me tell you, it is good that it is a kind of blessing that we will not be able to hear everything. See, when I close my fist, there is a sound that is produced at the joints of each bone and each finger. When I close it here, there is a sound produced at each and every joint, which is way less, coming around 10 hertz, okay, 15 hertz, which is very irritating. Now if you are able to hear the sound whenever I move my hands, whenever I move my fingers, whenever I move my neck, whenever I walk, a sound is produced and that sound you are able to hear. Is it not disturbing? Very, very, very disturbing. So we should consider that to be a blessing that we don't hear few sounds. However, some animals are sensitive to those sounds. Bats, which are sensitive to ultrasonics, they can hear very loud sounds. Okay, I mean high frequency sounds. Okay, similarly dogs. Okay, so these will be able to hear few sounds. That's the reason why they actually behave weird, because when they will be communicating with other dogs or other bats. Okay, and about this you will be learning in your higher classes once again. So this is your chapter for the test in the nutshell. All the best for your test. Hope you will be coming up with flying colors. See you again in the next class. Until then, bye bye.